probably couldn't hurt us. So, number one here, we have determined the point estimate of the population proportion. What am I talking about when I say that? P-hat. The margin of error for the confidence interval. We need our p-hat, we need the error, and the number of individuals with the characteristic. So that's like x. If n is 1,120, a lower bound is 0.051, and the upper bound is 0.074. So what I gave you is the confidence interval, and I want you to work backwards to find all the original information. So if our confidence interval went from here to here, what's the number in the middle represent? That's our p-hat. Remember, we built confidence intervals around p-hat and x-bar. So it's p-hat plus or minus our margin of error. So to find the p-hat, we just need the average of those. If you add them up and divide by 2, we get what? Then the error is the amount you add or subtract. So here is the error, and this is the error. So what's one way we could find that? Okay, so you subtract 2 of those, and we get the error to be? And then we need x. Yes.
When I put it inside, it comes out after me.
But everything else looked good. Thank you. How do we find x? It is a great question. How do you find p-hat? What's the formula for p-hat? Flip them. X over n. So if my p-hat is 0.0625, that's equal to x over n, 1,120. So my x, the number with the characteristic, had to be 7. Any questions there? Number 2, construct a 98% confidence interval for p-hat with x equals 80 and n equals 200. Let's look at our formula sheet. When I'm talking about my confidence intervals, we're in chapter 9, we have 2 formulas, one for p-hat and one for x-bar. So we're talking about p-hat plus or minus z alpha over 2 times square root of p-hat minus p-hat over n. So we can do it by hand, we can do it on the calculator. Let's do this one by hand for practice. We need the p-hat. How do we get that? Eighty out of 200 reduces to 0.4. Okay, then we need the z alpha over 2. So remember, if there's 98% in the middle, how much is left for the ends? 1 on each side. So we have to look up when our area is 0.99, so 99% below. And so we're looking inside the table to the closest we can get to 0.99. So that would be 0.9901. and that is at 2.33. Also, some of them it gives us at the bottom is 98%. One of the Z alphas given at the bottom. Yes, so you can double check it that way. Does everybody know how I got the 2.33? Okay, so now we have what we need. So we have 0.4 plus or minus 2.33 times the square root of 0.4, 1 minus 0.4 divided by n, which was 200. So my confidence interval is 0.3193 to 0.4807. So I'm 98% confident the value is between those two numbers. Is that one okay? All right. A survey of 1,153 workers and retirees in the U.S. 25 and older found that 496 had less than $10,000 in savings. Obtain a point estimate for the population proportion. Point estimate, that means p hat. So how am I going to get it? Four, three, zero, two. So then a 95% confidence interval. So we did the last one by hand. Do you want to do this one on the calculator as a refresher? So where do we go? Mm-hmm. So we have to decide, the t interval is when we're doing around the population mean, the x bar. What did we do today? So one proportion z interval is a. If you're not sure, check one. I mean, if you go into like number 8, if you pick that one, it's going to ask you questions that you don't know. It asks you for the mean, the standard deviation. We don't have that information, so I know that's not the right test. If I look at A, is that what we said?
Yeah.
Okay, so it asked me for an x. Do we have an x? Yes. 496. Do we have an n? Yes. 1153. Confidence level? 0.95. So let's calculate. And we get 0.4016, 0.45876. And so when in doubt, just go into one and look. The prompts, if you don't have the information, that probably means you went into the wrong one. Any questions on that one? All right. So now let's do some of the same things, but with the mean. So number 4, determine the point estimate of the population mean. So I'm asking you for the x bar here and the margin of error for a confidence interval with a lower bound of 15 and an upper bound of 35. So the x bar is in the center. Add them up, divide by 2. Get 25. So how do we find the error? Subtract. You can do 25 minus 15 or 35 minus 25. It doesn't matter. You should get the same thing. So our error was 10. Few more. Any questions on these so far? Is it coming back to you? A simple random sample of size n is drawn. The sample mean is 35.1. The standard deviation is 8.7. Construct a 90% confidence interval for the mean if the sample size is 40. All right, let's practice doing one by hand. If we have 90% confidence, that means 90% in the middle. So 10% left over, split over the two ends. So with this, if you're looking at your formula, we have a T alpha over 2 that we have to find. So we're looking at 0.05. Now when you go to that T table, it asks for degrees of freedom. How many degrees of freedom do we have? It's always n minus 1. So that would be 39 degrees of freedom. Okay, so if I go to my table for my T, not all of these are on here, but 39 is. And then our area in the right, the alpha over 2, is 0.05. So what do we get for the T value? 1.685. Everybody make sure you can find that. And then our formula, under chapter 9, our confidence intervals, which is x bar plus or minus the T alpha over 2. So we already have the x bar, we already have the T alpha over 2, times s over the square root of n. So we have everything we need. The sample mean was 35.1. T alpha over 2, 1.685. Standard deviation was 8.7. Divided by the square root of n, which was 4. So everybody get that to work out? B, if the sample size is 18, what conditions must be satisfied to compute the confidence interval? Right, so that's really asking about our criteria. If we're talking about the sample mean, what are my criteria? What do I have to have? Either the data has to be normal or the sample has to be greater than 30. If my sample is only 18, is that greater than 30? No. So in order for this to work, what would have to be true? Yes. So don't forget about our criteria. All right, let's refresh. I think I'm going to skip this question. I'm going to do the very last one. We'll do it on the calculator. So let's say I gave you this data. This was age and weeks at which babies first crawl based on a survey of 12 mothers. Assume the data is normal, so our criteria is set. Construct a 95% confidence interval for the mean age at which a baby first crawls. What do I have to do first? Yep. So go to stat, edit, put everything in your L1. so then which one do we go to? When we're talking about the mean, that's the t for our variable. Okay, then we have two options. We can base it off data or stats. Stats means we already know the mean standard deviation to plug in, which I don't. We put all this in our L1, so we're basing it off data. List is L1. Frequency should be 1. Confidence interval 0.95. So we get 31.896, 44.604. So this means we are 95% confident the mean age at which babies first crawl is between 31.896 and 44.604. Any questions? Yes. I'll get that. All right, are we good with this stuff? So now you have time to finish up your chapter 9 packet that's due tomorrow. And we are at the end of this next unit. So if you get done, I have the study guides for you.